So good afternoon, yet again, statisticians. This is the second video of the day. I was going to jump into probability, but I saw that at the end of this module, I'll show you right now by sharing my screen, that you have the part one of you have part one of, sorry, my bad. Sometimes it doesn't want to be my friend, especially when I have this at the top. So I gotta move this to the bottom. So, so just so you know, I did 1 through 3, the review. Uh, I did 2.1, 2.3, the review. I did the demonstrate stat previews. I did the 3.1, the discussion article, 3.2, 3.3, lab 1, chapter 3 review, and stuff about the test. This is if you fail it or if you, I saw you were cheating, you got to do the other test. Please don't cheat. I did 2.4, 10.1, the quiz, 10.2, but now I get to do part one of this descriptive stats of whatever you want. I'm pretty sure I did vision before, so I'm going to stick with vision. Sorry, I don't need this. And I'll just show you how to do it, and then I'll jump onto probability. I really like probability. It's like one of the things that I think will be the clearest for me to explain. Plus, there's a lab in it, so I'm excited for these. This chapter should be great. So we'll get there, right? We'll get there together. So I'm going to start with this project part one, your descriptive stats. So look over your first project, the assignment you did. If you make changes, make changes. So part one, use the data set that you did described in section two. So we need to do all the descriptive statistics. So that's mean, median, standard deviation, mode, range, min, max. Describe the data in a way that to clarify the purpose of the study. All graphs should do the same. With the purpose of the study in mind, describe the characteristics of the data set. Okay, so you have to give me your graphs, conclusions, your initial hypotheses. We'll have a summary with relevant statistics and graphs. I'd prefer this in APA form. Doesn't say APA format in here, but I would do it in APA format because that's how it would look like if you were reading it on a research paper. So for APA format, if you need APA format to like describe any of your results or like how to do any of this stuff, I'll show you where to find that. So, and I'm just gonna do the one for vision. Why vision? Because I did it before, and I just feel like it's an easy data set to work with. Sorry. You go back to the intro, and we click here. It'll show you exactly how to do the write-ups for your descriptive stats. So, like if you're going to do a linear regression, you can click this, but also like when you go into this for the result statements, it'll show you exactly like what's italicized, what's not italicized. Just so you can see how it is. All right, so let's get back into the book. And I'm going to find this appendix 2 business. Okay, maybe I can't find appendix 2. Well, I'm going to look for appendix 2. I'll find vision and I'll use some descriptive statistics. This is going to be probably a short video. Try to keep them short. Sorry, the last ones have been so long. I just know that there's a lot in here. So I'm in the book, appendix B data sets. We want vision. There's vision. I don't know why I picked vision, but that's the one I picked. So data from 300 subjects, the first 5 are shown here. How do I get them all? Oh, yeah, I forgot. So to get all the 300 subjects, we need to go to the stat crunching. And I'm going to put this in Excel just because I'm better with Excel, even though I don't use Excel a lot, but I don't really use all these a whole lot. So I'm going to go to Vision, Data Sets. Here's Vision. And I'm just going to click up. Now, Do we have to copy and paste this in Excel? Honestly, no. I was about to, but whatever. Remember that 0 was female, 1 was male. That's something I do remember. So first thing I'm going to do is actually, I said I was going to use Excel. No, I'm going to go to summary stats, by columns. I want them all. And we're going to get, I'm going to just literally click everything that I know. Oops, sorry about that. Let me start from the beginning. So I have to hit control to get them. I don't think we've done standard error a lot, but I'll have that in median range in max Q1, Q3 sum IQ R. Have to do a coefficient of variance and a mode. Remember, mode didn't come out. That's why I didn't want to use it. So let's compute this thing. Boom. Ta-da. So here we go. We got age, the amount, there's 300. There's the mean standard deviations. Oh, it does give you the modes here, 46, 0, 20, and 20. So this is everything you can use. This is the information you're going to have to provide. Now it says it wants some graphs. So I would make some histograms, some basic histograms. Oh, we can do a box plot too. We'll do box plots of all 4 things. Let's also have a median and mean markers. I think that's fine. Let's look at them. Oh, okay. So look at all these outliers, and they're barely related. Well, gender shouldn't be in there. So I'm going to do this again without gender because there's just 0s and 1s in there. It's kind of throwing off my vibe. So I'm going to take out gender. So I want age, right eye, left eye. Actually, let's leave that one out. Let's just do right eye and left eye, and we're going to do age as well. Here we go. Interesting. Interesting. So these are our box plots, which are nice. I would copy and paste them, give them a title, make them look nice. Now for certain things, like you could, so we can look at it as a box plot. We could also look at them like a histogram. Like maybe I do a histogram for age. I think that would be interesting to see. But these are your descriptives. It's pretty much everything is right here for you. Let's do a histogram of the age. So we can say what we want to start with for age. I'm pretty sure the youngest is 18. So why don't we start with, let's start with 15. Let's go up and make each width 5. I'll also put the markers in, just so we have the mean and the median. Let's see how it looks. Nice. So here we go. It's got more of a tail on the right, so you can see it's like slightly slightly positively skewed or slightly skewed right. But this looks pretty good. So this would probably be the stuff that I would include. Histogram for age, right eye and left eye, box plots, and this. Now, I really hate the way these box plots look. I think they're real ugly. So you know what the first thing I'm going to do is I'm going to copy these two. It lets me. So I'm going to copy these two and put them on Excel so I could just make some box plots that look nice. You can make your box plots by hand, which isn't that hard using the quartiles, right? So this is everything that's done on StatCrunch, but I'm going to also just do one of these on Excel just for fun. Welcome back. So here we go. I'm just going to make a box plot for left and right so it looks nicer. So insert. Here are my box plots. I think it's because they're both starting at 2020 and then it goes up. So like the whole thing looks a little strange, but I don't think it's too bad. The one thing that I do want to do is just make sure if I am using this, I'm going to include the middle. I hate throwing stuff out. I also want to include the middle here. And I'm going to do what with these? I'm going to put labels on them. Boom. I'll put labels on this one. Boom. The box plots don't really help me because everything's like above it, which is really interesting. I think it's because it starts with 20 and there's nothing lower than having 20/20 vision. So I'm not sure if a box plot is actually the best source for this. So what am I going to make? I think I should make histograms for both of these. So let's see how they look on as a histogram instead of a box plot, just because these aren't the best. So to make this into a histogram, though, we actually have to get the values. So we'd actually have to count these all up, and there's 300. There's a lot of these, so I don't know. Maybe I'll do a column graph instead. Let's try 2 column graphs. That's tough. Most of these graphs aren't giving us a lot, right? Even the line graphs aren't giving us a lot. So this data is really hard to work with for without doing the other exams. Like, I don't know how well this box plot does. Maybe I can do a pie chart to see what percentages are of each value. I think that might be the best. I'm having a hard time finding a way to visualize this data without losing pieces. So let's look at a pie. Okay, let me do one eye at a time for the pie. It is giving me nothing. Oh, because these aren't in percentages out of the total. Either way, I'm not getting like a good sense of this value. I thought if I did this out of 300. Okay, so my total's 300, right? My total's 300. So first thing I'm going to do is I'm going to order this one and sort it. I'm just trying to find a good way to look at this data, but it's so big that it's giving me some issues. Sort this thing, expand and sort, so they're all matched. Perfect. Okay. Okay, so this is what I'm gonna do. Making a table. It's the best way to do it. And I can make a histogram based on the table or a pie chart. So I'm gonna do range of vision, and we're just doing the left eye first. This is just left eye. So we know we've got 20. How many 20s do we have? I believe it's 150. See, sometimes you just got to work with the data, like you work with what you got, and you got to just make it look the best you can. So the first one, here's my little table. So here it is. We know we have 155 people that are 20. So we're going to call this frequency, relative frequency, and then cumulative. And this should really help me visualize this data. Like this. All right, so that's how many 20s we have. How many 25s do we got? Nope, I'm already at 30. So there's 66 25s. Okay, so there's 66 25s. All right, how many 30s do we have? I've already done. There are 19 30s. Okay, how many 35s do we have? Oh, we just go to 40. How many 40 visions do we have? We've got 17 40s. Okay. How many 50s do we have? 50s, I have 287. I'm sorry. 50s, I have 29 50s. Notice I'm just looking down here every time. Just so you can see how to use your data and make it look nice, you order it and then you can just count them up. All right, how many 60s do we have? 2. Two 60s. And now when I make the pie charts and everything else, it'll look really nice. How many 80s do I have? I have 4 80s. And how many 200s do I have? I've got, sorry, 5 200s. Now, how can I make sure I did this correctly? I can add these up and just make sure it's right. Just gonna bold the top so it looks like a option thing. How can we make sure we did this right? We could just do equal sum. Does that say 300? 297. Off by 3. To go down to 300. Yeah, goes down to 300. Okay, so let's go backwards. 5, 5, 80 we have 4, 4, 60 we have 4. Oh, I only have 2 here, so that's 4. And now I'm only off 1, okay. 60 we have 4, right? For 50 we have 29, 29, 40 I should have 17. 17. 30 I should have 19. 30 is 20. Okay, so we have the 2 mistakes. Now it adds to 300 and we're good. So relative frequency, we just have to take the first one, divide it by 300. Now I have all my percentages. And we can make them into percentages real fast by hitting the percent button right there. And then cumulative is just equals the first one. Then it's equals the one above it, plus the one next to it. This is everything we need. So use whatever tables you want, whatever graphs you want. But now when I make my histogram, I'm going to be good. So I'm going to go to, and I can make this a pie chart too. I'm going to do both. I'm going to make it a pie chart and I'm going to make it a histogram. So let's insert some stuff just using these first two. Let's insert a pie graph. Let's do the pie. Beautiful, beautiful. If we want the labels to be different, that's fine. We could actually put the legend. Boom, turn on the labels. And it'll tell me what is of each of them. Ta-da! Oh, I gotta put up with it. What's it called? I'll fill around those labels. Beautiful. Nice. So this is all the visions. The most should be 20. I don't know why it says 200. Unless I did it backwards. All right, well, let's look at the histogram. Let's see if there's something wrong with this. Okay, because I have 2 parts of the line. Being really weird right now. Going to open Excel and see what happens. like how I said I was going to be short, and then I'm just messing around with graphs for a half hour. Sorry about that. Choose the top three things you're willing to highlight. Yeah, just take your time. What would you like in it? Okay, I don't know why I have one for each of these. These are just the labels. Oh, I think I just need to have this in it. Yeah, that's why. And then I'd have to make these the values. So I'd have to like change these to being like 20, 25, put those here as my y-axis. But that's how it should look. I think I have to do the same thing for the pie chart. Nice. And then I would just have to put in labels for these. So I was having so much difficulty with that, but at least now it looks right. The pictures look right, so I'm more happy. Put in what you like for these. Take your time. Do you have to use vision? No, use whatever one makes sense to you. Just take your time. Put in this data, the purpose of the study. To me, I think it's like men and women versus eyesight. You do t-test. You can say, does your left eye predict your right eye? Does your right eye predict your left eye using regressions? Either way, you know, you can say that women have, you could, I think a really good way to break down this data. Let's go back to where the original data is. Go to where this original data is. I would think stuff about like men and women with eyesight. I'm pretty sure that's what they want to see. Here we go. All right. So what's one way I would do this? I would do something like this. And you can use either one, either program you like. But I'm just going to take all the data and put it into Excel, separate it between men and women, and look at the differences between like overall. I basically want to do a t-test, but because we haven't done a t-test yet, because we haven't done a t-test just yet, and it doesn't even have t-test in there, which is kind of annoying. I would take this value and I'm going to sort it, but I have to expand it because each one of these data is relied to one person. And I would just take all of the women's eyesights. And we could break it down by age too. We could stratify it using age, but I'm just going to do equal. So I'm going to write women's left. I'm going to do one for women's right, men's left, and men's right. That's all I'm going to do. So this is men because I think, wait, 0, I think was female, 1 was male. So we're starting with the women's left eye. And all I'm going to do is find the averages, but you can find the averages and standard deviations of all of these. Just so I have space for this table. I'm going to do average. Well, we'll do mean. You can see if the ranges are different. We can see if the standard deviations are different, but I think the mean and standard deviation would be a good way to look at this just to start. So equals average. And here's the first group. Now, if we did a t-test, it would do it all for us automatically. But we haven't gotten to t-test yet, so I don't want to just jump the gun. And since t-test isn't any of yours, which is kind of weird, I'm okay with that. All right. So here we go. This is the woman's left eye. Boom. We'll do the woman's right eye. We know it's from C1 to C54. So basically, I can just copy this and just change them to D. Was it 154? Yep. Awesome. I'm just going to copy this. Nice. So that's our standard deviation. All I have to do is change these to these. Cool. Now we're going to look at the men's. I'm going to do the same idea, except now it's going to be from 155 to 300. So what do I mean? C, C. I need from 155, 300. There we go. Then we have the men's right eye. So all I have to do is change this to D. D. And I need to do the standard deviation. Okay, so here it is. So these are all the means and standard deviations. You can look at the ranges, you can look at anything that's different, but I'm basically separating the vision between men and women. This is woman's left eye, boom, 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 boom. This is the men's left eye, men's right eye. You can make one score for this women's and one score for this men's, but you can see that the women obviously have slightly worse eyesight and have bigger variation. That's something you find right away from the descriptive statistics. Now, how do we figure out if they're statistically different? Just a little like intro, you know, just so we can get there. I'll do a t-test just for fun. T-tests. Two sample, two means paired, two sample per means. Oh, we don't have a one. Okay, so the variable one range. Let's see what it looks like on the other one. I haven't done t-tests on this in a minute, so let's see if we can do one here. I'm just curious. Say it's one sample. So the columns are going to be left eye and right eye. group by gender. There we see, you have to have the group by gender. And let's just compute this and see what happens. It is a significant difference in gender. These are our sample means. These is the error. That's degrees of freedom. And yeah, so the gender does matter between total eyesight. This is for right eye and this is for left eye. They're both significantly different. Ta-da. So this is showing you that these means are so different that it's significant, which is pretty cool. And I can go more into it, but that's like what I would want to know at the end. But right now we can just say that they're not significantly different. We could just say the means are different and standard deviations are different, but I just showed you that they are in fact significantly different. So I could show you more about t-test, but it's just like, are the means different enough to be significantly different? All right, well, that was a long video. I hope it was useful. I'm going to do some probability videos. And if you have questions, if you're worried about anything, right? If there's anything that you need from me throughout this process, more information, you want to do your own study, more than happy to help. Enjoy your day.